Hi, today we're going to be evaluating piecewise functions. Now, evaluating piecewise functions, just like evaluating any function, would really most of the time just mean plugging x value in. So, for example 1, it asks us to evaluate it at 2, 5, -3, and 0. So we're going to take our equation and plug in 2, 5, -3, and 0. Now when you're talking about piecewise functions, it's important to notice which equation it gets plugged into. So you have to look at the domain. So let's look at example 1. Well, we're dealing with, on the top, x being less than 0, and on the bottom, x being greater than or equal to 0. So we'll use the top for negative numbers and the bottom for everything else. Right? X is greater than or equal to 0 for x, so even 0 will be plugged into the bottom one. Okay, so let's find f of 2. Well, f of 2 is greater than or equal to 0, so we will use the bottom equation. Alright, and it's just x, so it's just 2. For 5, we are still going to use the bottom equation because 5 is greater than or equal to 0. So f of 5 is just 5, right, because you're plugging it in for x. -3 is less than 0, so we'll use the top equation. So we'll find f of -3, which is negative the number, so I'll plug in -3, which is just 3. So the answer is 3. And then for f of 0, that's still the bottom equation because 0 is greater than or equal to 0. So f of 0 will be 0. Alright, let's do something a little more complicated, right? It's going to require a little bit more work. Now I'm going to color code these again. Right, so I'm going to say anything between -4 and -2 is in red, -2 to 1 is blue, and greater than 1 is purple. Alright, so 2. Well, 2 is greater than 1, so it's going to be purple, so we're going to use that equation. So to find f of 2, we're using the equation 2x plus 1, so we'll have 2 times 2 plus 1, which is 4 plus 1, which is 5. Now let's find f of 5. Well, 5 is greater than 1 also. So I'm going to use the same equation. So we'll find f of 5, which is 2 times 5 plus 1, which is 10 plus 1, which is just 11. Okay, let's plug in -3. Now -3 is between -4 and -2. So I'm going to use the red equation. So f of -3, is x squared, so it'll be -3 squared. Well, -3 squared is 9, right? Because -3 times -3 is 9, so the answer is 9. And then 0. Well, 0 is between -2 and 1, so we're going to use the blue portion of the equation. So f of 0 is going to be x minus 3, so 0 minus 3, which is just -3. And it really is pretty much that simple when you're actually evaluating. Now another thing we'll want to determine is whether a function is continuous or not. Now, as long as the equation is continuous in general, the only part we have to worry about is where it switches from one equation to another. So in the case of f of x here on the left, okay, we're worried about 0. Because on one side x is less than 0, and on one side x is greater than or equal to 0, and it's very possible that it'll do like what you saw when you graphed it, and jump from one equation to another. And if that's the case, then our function is not continuous, remember, because if it's continuous, we don't have to pick up our pen. So, or pencil as the case may be, right? So what we're going to do algebraically, if we don't see a picture, is take that 0 and plug it in. Okay, we'll plug it into the left side and the right side. Even though it's only defined on one side, we still want to see what's happening on the other. So, if I plug in 0 to the left, that means I'm plugging it in where it's less than 0. Then I end up with -0, which is still 0. If I plug it into the right side, so where it's greater than or equal to 0, 0 is still 0. Okay? So because on the left it's 0 and on the right it's 0, that means that because 0 equals 0, the function is continuous. So therefore, and I'm going to use little dots, right? That actually represents therefore. I don't know if Mr. Bryan ever showed that to you when you took geometry, but that means therefore the function is continuous. All right, let's look at this other one. Right, it's a little more complicated. So let's start with the -1. Now, there are 2 breaks in the second equation that you see, or in the second function. Right, we have one at -1 and then one at 2. Now, if one of them doesn't work, then the function's automatically not continuous. If one of them does work, then we need to try the other one and see if that works as well. So let's just try -1 first. So to the left of -1, we'd be dealing with the very top function, right, 2x minus 3. And then to the right of 1, we're going to be dealing with the absolute value of x minus 5. And we want to see if on the left side, so for the 2x minus 3, if I plug in -1, is it equal to the absolute value of -1 minus 5, which would be from the right side. So let's go ahead and plug them in. If I plug in -1 into the red equation, so the top equation from the left, I have 2 times -1 minus 3. Well, 2 times -1 is -2, minus 3 is -5. All right, so let's see that middle equation. If I plug in the absolute value of -1 minus 5, well, an absolute value means that it becomes positive, so we actually have 1 minus 5, which is -4. Okay, well, -5 is not equal to -4. That means that 1 will stop at -5 and it'll jump to -4. Which means that since -5 does not equal -4, the function is not continuous. Now, what if I'm given an equation with variables in it and I want to make it continuous? Like, my job is to make sure it's continuous. Then there's going to be some letter that represents a number that we're going to have to solve for so that it is continuous. If it is continuous, then when I plug in the number, so 5, right, in example 4, 5 is where it switches from one equation to the number, to the other. So when I plug in 5, I need the left side to be equal to the right side. So I'm going to plug in 5 and let C be C. Okay, then I'm going to take both sides and set them equal to each other because I want them to be the same. I'm going to make them be the same. And that'll give me the value that makes my function continuous. So let's go ahead and do that. Now, the left side is going to be the top equation, the right side is going to be the bottom, right, because one's to the left because it's less than, and one's to the right because it's greater than. And I'm going to plug in 5. So I'm going to get 5 squared minus C, which simplifies to 25 minus C. Okay. Now I'm going to plug 5 into the other equation where I see x. Remember, we're talking about x here. I don't know what C is. That's what I want to find. So now we have 4 times 5 plus 2c. Well, if I simplify that, I get 20 plus 2c. Now I want the left side to be equal to the right side. So I'm going to take 25 minus c and set it equal to 20 plus 2c. Now I'm going to solve for c so that this equation is true. So we know how to solve this, right? It's a linear function. We subtract 20 from both sides. Oops, that doesn't cancel. We get 5. Let me get rid of that. We get 5 minus c equal to, that cancels, 2c. Now I need to get rid of the c on the left, so add c plus c. 5 equals 3c. Divide by 3. And the c that would make this continuous is 5/3. And that's the answer to the problem. That's what I wanted to find. Okay, we will practice in class. Have a great day.